Alright, this idea is a little different here. But it makes a really good point about how to set up one ratio and another ratio and then cross multiply and divide, and how that really works and how the importance of units are. So it says the ratio of girls to boys is 3 to 5. And when it says girls to boys, that means the 3 is the girls and the 5 is the boys. It's always like that. So it says if there are 15 girls in the class, what is the ratio of boys to all students? All right. Now the problem here is that I have boys to girls to boys, girls to boys, girls, but I don't have all students. So I can't set up any kind of a ratio here to find the ratio of boys to all students because the units don't match. So it's important that this is a two-part problem. Part one, we can determine the number of boys. Yes, if there's 15 girls in the class and we have the ratio here of boys to girls, we can find the number of boys. Part one, we're going to determine the number of boys. The ratio of boys to girls is a part-to-part ratio. That means that you're dealing with part to a part. Students would be the whole, but you only have boys and girls, so it's a part-to-part ratio. In part two, we're going to find the ratio of boys to all students. The ratio of boys to students is a part-to-whole ratio. So that's the difference between a part-to-part and a part-to-whole ratio. So you set up a proportion and cross-multiply to determine the number of boys in the class. We use units to help us keep the correct order. Thing 1 is girls, thing 2 is boys. So there is 3 girls to 5 boys. So that's going to be equal to another ratio that has 15 girls, so I don't know how many boys. Cross multiply, divide, and we get 25 boys. So now we know that, and importantly, 3 over 5 is the same as 15 over 25. So we know there's 25 boys and we're being asked for the ratio of boys to students. We must add the number of boys and girls together to get the total amount of students. Therefore, the ratio of boys to students is 25 to 40. And you can reduce that, but that's what it is. So let's take a look at this. This is the ratio table. And here is our initial ratio, 3 girls to 5 boys. And then when we knew that there was 15 girls, we found out there was 25 boys. I just want you to follow along here and think about this. Our initial ratio that we didn't know, there wasn't 3 girls or 5 boys. But let's add those together. 3 plus 5 will give us 8. And from our initial ratio. And from our known amount of students, 15 girls and 25 boys, you add those together, you get 40. Keep this, pause and think about that if you need to think about it. So this is the ratio table. It's helped us to organize the information. We can see the ratio of boys to students. Boys to students is 25 to 40, or 5 to 8. Right here, 5 to 8. And if you would take both of these, make them fractions, if you were to reduce this or change 5/8 into 40ths, these are exactly the same, which is really important. That's how you go from a part to part to a part to whole. If we only have one ratio, it's good enough. Notice we could have simply have added 3 girls and 5 boys equals 8 students and arrived at this ratio immediately. In other words, we didn't have to go through 2 steps. We could also use number lines to visualize this. 3 girls to 5 boys, total of 8 students. the same ratio, double this, 6 girls, 10 boys, would give us 16 students, etc. This is the one we did, 15 girls, 25 boys, 40 students. Now notice this. 3 girls to 5 boys is the same thing as 6 girls to 10 boys is the same thing as, these are all the same. All these ratios are the same. So if these ratios are the same, you can just add up 3 and 5 and get 8. So the ratio of girls to students would be 3 to 8. The ratio of using this ratio, the ratio of boys to students would be 5 to 8, because I just added up the 3 and the 5. Now watch this. 6 plus 10 is 16 students. If there's 16 students, 6 of them are girls. So it's 6 out of 16. Boys, it's 10 out of 16. Notice that 3 over 8 is the same as 6 over 16, is the same as 9 over 24. These are all the same, and these are all the same. This problem could have been done in one step. So here's what we're going to do, one that's similar, okay? Suppose a local school has 1131 computers consisting of a combination of laptops and desktops. The ratio of laptops to desktops is 5 to 8. That means for every 5 laptops, there's 8 desktops. Find out how many laptops and how many desktops the school has. We cannot solve the problem directly with proportion because we can't do this. We can't go 5 laptops to 8 desktops and put computers down here. That goes back to a complete violation that the units have to be matched up. Using the ratio of laptops to desktops, we must find the ratio of laptops to computers. And what is the ratio of laptops to computers? No, it would be 5 to 13. 8 plus 5 is 13. You can use any ratio to find the total. And the ratio of desktops to computers is going to be 8 to 13. Now we can set up and cross multiply, right? So I'm going to set up, we can find out laptops first, okay? Now how would I set up this equation? Think about that. I pause it now. Think about how you would do that. And I'm going to put numbers in. So there is our equation. Notice I put the units in. 5 laptops to 13 computers is equal to another equal ratio of, I don't know how many laptops to 1131 computers, which I got from up here. So now I can just cross multiply and divide. But setting this up and understanding laptops to computers, and not laptops to desktops, I don't know the computers, that's not going to work. These are the same, these are the same. So if you want to do that, hit pause now and do that. I will put the answer in. So I finished the equation, cross multiplied, multiply these together, and then divide it both sides by 13, and I get 435, and I should put what that is, because that's going to be what X is, and that's laptops. Now think about it. Do I have to redo this for desktops, which would be 8 desktops over 13 computers equals X desktops over 1131 computers? The answer is, think about it. And the answer is no, because we know how many total that there are. And if we take away the 435 laptops, what's left is desktops, which is 696 desktops. Okay. So I put those in. There's 435 of those, and there is 696 of those. Did we need two proportions in the above problem, or could he solve the problem with only one? Explain. Well, I did solve it with one. I found the amount of laptops, and then I just subtracted that from the total. So the answer is no, you only need one. All right, it's our last example. It illustrates the complexity with dealing with ratios. It's not as simple as it seems. With the exception of dollars to pesos, we have used examples that dealt with alpaca students and computers. These are discrete units, meaning they weren't broken into parts, meaning they cannot be subdivided like a fraction, like a half of a child. That's not possible. There do exist continuous things like pesos and bushels, dollars, right? You can have a half of a dollar. You can't have a half of a child. Discrete means you can't break them into fractional parts. Continuous means you can break things into fractional parts. So here's just a quick example. The grocery store is a sale of 3 pounds of grapes for $5. 3 pounds for $5, right? How much will a half a pound cost? Well, again, it's a straight proportion. 3 pounds to $5 equals 0.5 pounds to N dollars. Cross multiply and divide, and you get 83 cents. Notice how setting up a proportion is a tried and true and will always work. Sometimes scaling the ratio, which we do with, that's what we do with equivalent fractions. When we go from 3/6 to how many 18ths, multiply it by a whole number. That's pretty easy. But going from doing the scaling here, we'd have to have divided the numerator and denominator by 6 to get this, so that really cross multiplying and dividing is much simpler. Remember, dividing by 6 is the same thing as multiplying by 1/6. So really what you're doing is taking 3 pounds, multiplying it by 1/6, and $5 multiplying it by 1/6. Much easier to go ahead and cross multiply and divide. And so here's our last problem. A 1/4 pound lobster tail costs $6.99. How much would it cost for 3 pounds of lobster tails? Now here's your first ratio, so write the thing down. I'm going to put it on, you put this on pause and I'll put that up. So there's our first ratio. We got it from the information here. And what we're trying to do then is find another equivalent ratio. Here, I'll move that over. Another equivalent ratio that is, trying to make that bigger. Another equivalent ratio that uses 3 pounds. So insert an equation here, and I need a fraction. And the 3 pounds is going to go on top. Pounds must equal pounds, and dollars must equal dollars, and I don't know how many dollars, X dollars. So go ahead, pause this thing, and see if you can come up with the answer, and then restart it. So if you cross multiply and divide, it's 1/4 times X equals 699 times 3, which I have there. And I just multiply these together, so I get 1/4 X equals 20.97. There's one more step. I don't want you to think about it. Pause this thing, think about it, and I'll put down the answer here. So there's the last 2 steps I added. instead of dividing both sides by 4, that should be a 4 there. Instead of dividing both sides by 1/4, I multiplied by 4. And so 4 1/4 is the same thing as 1/4 plus 1/4 plus 1/4 plus 1/4, which is 1. And so I'm multiplying that, and it costs $83.88 for 3 pounds of lobster tails, if a quarter pound costs that much. And that is the end of 4.1.